Why did ancient humans begin cooking? The obvious answer seems to be that cooked food tasted better. But try placing yourself in their world, a world with no matches, no stove, and no guarantee that a fire would survive until morning. From an evolutionary perspective, stopping to make a fire was a strangely irrational thing to do. Every other animal on Earth eats its food raw. Chimpanzees chew fibrous plants. Lions tear fresh flesh. Bears pull roots from the ground. None gathers fuel, produces heat, and waits before eating. For millions of years, your ancestors also lived in that raw world. Imagine that you are hungry, yet you still have to search for dry wood, keep the fire from dying, and sit there while the food cooks. Smoke stings your eyes. You cannot keep moving. When night falls, the flames reveal your location to predators and rival groups. Cooking was anything but an easy shortcut. That was an extraordinary amount of work and risk if the only reward was better flavor. So the real question is not why humans eventually enjoyed cooked food. It is why natural selection continued rewarding a behavior that was slow, dangerous, and unlike the feeding strategy of every other animal. The answer begins inside your own body. We usually think of cooking as a cultural invention like pottery or the wheel, but you only need to look at your own body to see that the story may run deeper. The human body is organized around unusually high-quality processed food. Look at your own teeth and jaw. Compared with other great apes, humans have relatively small teeth and chewing muscles. Our digestive system cannot be reconstructed from fossils, but living humans possess a comparatively small colon and an energetically expensive brain. Though only about 2% of adult body mass, the brain consumes roughly 20% of resting energy. Large brains are costly, while wild raw foods are often difficult to chew and digest. Imagine having to chew coarse food from morning until night merely to fuel your brain. Neuroscientist Susana Herculano Hosel estimated that a primate supporting the human number of brain neurons on an unprocessed raw diet might need to feed for more than 9 hours a day. The precise estimate is debatable, but the constraint is real. Energy must be obtained before it can support a brain. Richard Wrangham's cooking hypothesis offers one possible explanation. It proposes that habitual cooking increased the energy available from food and contributed to the evolution of the genus Homo. A related idea, the expensive tissue hypothesis, developed by Leslie Aiello and Peter Wheeler, argues that evolutionary changes in diet and anatomy helped make a costly brain possible. But keep one boundary clearly in mind. These are hypotheses, not a settled verdict. Meat eating, stone tools, pounding, fermentation, and changes in activity may also have mattered. Fossils cannot reveal exactly when a digestive tract changed. Perhaps humans did not simply grow intelligent and then invent cooking. Repeated food processing may have helped create the energetic conditions for a more demanding body. That possibility creates a puzzle. Early Homo erectus appeared by about 1.9 million years ago with longer legs, changes in the face and teeth, and an expanding brain. If habitual cooking helped produce this package, fire should appear near the beginning. Yet archaeology gives us a later fragmentary record. At Wonderwork Cave in South Africa, microscopic plant ash and burned bone lay deep inside sediments dating to roughly 1 million years ago. Their condition provides strong, early evidence of fire inside a living space. But can ash and burned bone prove cooking? Not yet. Fire could provide warmth, light, protection, or a place to work. Clearer evidence comes from Gesher Benot Yaakov in Israel, where fish remains date to about 780,000 years ago. Pharyngeal teeth clustered near hearth activity, and their crystal structure was consistent with controlled heating. Hominins probably cooked fish there. Place those dates together. Homo erectus at 1.9 million years, strong fire evidence at 1 million, and persuasive cooking evidence at 780,000. You can see the problem immediately. Where then are the missing fires? Perhaps early cooking vanished under weather, trampling, animals, and geological change. Or perhaps it began sporadically and became habitual much later. Part of the confusion comes from treating several achievements as one. Ask yourself, is using fire the same as creating it? Hominins might exploit wildfire without preserving a flame, or carry embers without igniting a new one. Fire may have provided warmth and protection before regular cooking. Occasional roasting is also different from depending on cooked meals daily. Each transition could have occurred at a different time, while archaeology captures only the traces that survived. There's also another possibility. Before humans could use heat to process food, They had already learned to process it with force. The natural world was never empty of calories. The problem was that many calories were physically locked away. Imagine standing before a tough root or carcass. Starch is buried in the root. Protein and fat are enclosed by muscle, skin, and bone. Food is in front of you, yet its energy remains physically locked away. Long before controlled cooking can be demonstrated, hominins made stone tools. Sharp flakes sliced flesh. Hammerstones crushed bones for marrow or pounded hard plants. Catherine Zink and Daniel Lieberman tested these behaviors with volunteers chewing raw goat meat and plants. Human teeth struggled with raw meat, but slicing meat and pounding plants sharply reduced chewing force and frequency. Their model suggested that simple tools could save early humans roughly 2 million chews each year. Stone tools did not create a large brain by themselves. Mechanical processing simply solved part of the problem that cooking would address more thoroughly. When you cut meat with a sharp flake before raising it to your mouth, the stone acts like an extra set of teeth. A hammerstone performs work that the jaw no longer has to perform. Processing begins before you swallow, outside the body. That distinction matters. Hands and tools were already reducing the cost of eating. Mechanical processing could support dietary change while controlled cooking remained rare or unreliable. This may explain how early Homo reached a higher quality diet before reliable cooking became universal. Cutting, pounding, and marrow extraction helped bridge the archaeological gap. The first external stomach may not have been a fire. It may have been a stone. But stone could alter only the size and shape of food. Heat could alter the food itself. Bury a starchy root beneath warm ash and its structure changes. Heat and moisture gelatinize the starch, giving digestive enzymes easier access. Fire creates no new energy. It unlocks what is already there. You can feel the difference. Heat unfolds proteins and can soften connective tissues. Too much heat toughens meat, but proper cooking reduces the work of chewing and digestion. Fire begins working before food enters your body. Rachel Carmody and colleagues tested this with mice. Animals given cooked meat maintained more body mass than those given an equivalent amount raw. Thermal processing changed the net energy their bodies received. Mice cannot date the first cooked meal, but they demonstrate a mechanism. Equal-looking portions can deliver different usable energy after processing. What matters is not only what enters the mouth, but what the body retains. Cooking also expanded usable foods. Heat kills many pathogens and parasites and can reduce some plant defenses. Foods unsafe or inefficient when raw became more valuable. When sugars and amino acids react under heat, the Maillard reaction creates aromas you still recognize in browned meat or bread crust. Ancient humans knew no chemistry, but remembered that smell led to a satisfying meal. Imagine the repetition. Food falls near embers. Someone retrieves it. The texture and taste differ. Later, another piece is placed there deliberately. An encounter becomes a remembered action. No prehistoric genius had to imagine a kitchen. Simple comparison was enough. One root caused less discomfort, one piece of meat required less chewing, burned food satisfied hunger longer. None explained calories or bacteria, but each offered a reason to approach heat again. Repeated success turned curiosity into expectation. That transition matters more than the first cook's identity. The breakthrough was not tasting food altered by heat, but reproducing the change, preserving the fire, and teaching someone else. Fire was no longer just a dangerous event in the landscape. It was becoming a tool. The value of cooking did not end in the stomach. It changed the use of time. Place yourself beside the hearth. You must gather fuel, maintain fire, guard food, and wait. You cannot walk away while the smell announces the meal. You cannot solve everything alone. If you tend the fire, who finds food? If you hunt, who protects the meat? People returned to a shared location while others collected wood, processed ingredients, or guarded the meal. Cooking did not invent cooperation, but made it more regular and visible. Enter Qasem Cave in Israel around 300,000 years ago, and you would see more than accidental ash. A repeatedly used central hearth organized different activities. Fire had become part of the space. Soft food widened the circle of people provisioned. Children, injured adults, and older individuals with worn teeth. Cooking did not create childhood or old age, but made one meal accessible to different bodies. If you were injured, young, or missing teeth, processing could turn food into care. A meal no longer belonged only to whoever was strong enough to tear it apart. That created a new kind of dependence. The person receiving softened food depended on someone else's labor, while the group retained a member who might contribute knowledge, childcare, toolmaking, or experience. Cooking changed not only who could eat, but who could remain useful within the group. The hearth also extended the day. Anthropologist Polly Wiestner found that Zhuangzi daytime talk focused heavily on practical matters, while firelight conversation shifted toward stories, distant people, relationships, ritual, and imagined worlds. Modern hunter-gatherers are not fossils, so the study cannot reveal what Homo erectus said. It shows only that firelight creates a social setting different from daylight work. Cooking provided calories, but the hearth created an audience. And once knowledge had an audience, it could travel farther than one lifetime. Now follow ancient humans away from a single hearth and across different landscapes. You will not find one prehistoric cuisine. In each environment, controlled heat became a flexible answer to a different nutritional problem. Beside a lake or coast, fire opens different foods. Gesher Ben Not Yaakov shows heated aquatic food hundreds of thousands of years ago. Much later, at Pinnacle Point, early Homo sapiens exploited shellfish and heat-treated silkcrete for stone working. You see not one timeless recipe, but separate experiments. In a cold region, fire solves another problem. You can roast roots beneath ash, trap steam in an earth oven, or warm water with heated stones in a container that cannot touch flames. The earliest dates are uncertain because skins, bark vessels, baskets, and wood decay. Fire-cracked stones show heating, but not always its purpose. This is why you must resist filling every archaeological silence with a confident story. A vanished container may hide a real technique, but absence cannot tell us which technique it was. The evidence permits possibilities. It does not make all possibilities equally probable. Possibility is not evidence, so the details must remain cautious. Controlled heat offered many solutions: roasting, drying, smoking, warming, softening, and indirect heating. But choose the wrong fuel, temperature, or timing, and the result changes. A tuber may remain toxic, meat may burn outside while staying raw within. A heated stone may fracture the moment it touches water. Success depended on observation. Which wood produced lasting coals? Which roots needed prolonged heating? Which stones survived temperature changes? Cooking was not one invention completed in a single night. It was a growing library of solutions revised wherever humans carried fire. An accidental heated meal requires opportunity. A reliable cooking method requires memory. Suppose you discover that a root softens in ash. Keep it secret, and the knowledge dies with you. If others watch, imitate, and teach it, improvements accumulate. One generation learns placement, another wrapping, another the best season. You no longer have to rediscover everything for yourself. This is cumulative culture. Knowledge does not return to zero with every generation. Human societies preserve useful changes and build on them. Cooking did not create cumulative culture. Stone tools already show learned behavior. But the hearth became a classroom where mistakes and successes were observed together. It was also a classroom with immediate consequences. Place a root too close and it burns. Remove it too early and it remains hard. By watching the result, you learn not only an action, but timing, judgment, and the subtle signs that tell you when the action has worked. See the scene through the eyes of a child beside the hearth. You watch adults collect, cut, pound, place, turn, test, and divide. No one must explain every principle. You learn by paying attention, then one day reproduce the sequence yourself. Processing expanded into drying, smoking, soaking, grinding, fermenting, heating, and storage. An artificial digestive system spread across tools, microbes, and knowledge. Biological evolution alters populations across many generations. Cultural knowledge can alter a group's chances before the next winter. This helped humans enter environments their bodies were not specialized for. Instead of evolving a new organ for every food, people carried methods. By this point, cooking was no longer a trick used whenever flames happened to be available. It had become part of the human environment itself, an environment built and maintained by people. Cooking eventually changed the distance between a meal and the moment it would be eaten. For most animals, food belongs to the present. Carcasses spoil, fruit disappears. If tomorrow's hunt fails, today's success cannot protect you. Humans interrupted that timetable. Heat aided drying and smoking. Fat could be rendered and meat divided for transport. Direct evidence is scarce, but Chasm Cave preserves a glimpse. Cut marks suggest skin-covered deer limbs were stored and later opened for marrow between roughly 420,000 and 200,000 years ago. This is evidence of storage, not cooked marrow. Its importance is that people were protecting energy for a later need. Imagine choosing not to finish available food. A meal can accompany movement, and surplus can bridge a failed hunt. Planning becomes visible in the portion deliberately left uneaten. Storage changes the uncertainty a group can survive. A small reserve separates hunger from the latest hunt, allowing people to shelter during dangerous weather, travel farther, or repair tools. Food may spoil, be stolen, or attract animals, but some risk can now be managed in advance. That reserve also changes how you experience time. Hunger is no longer tied entirely to what the landscape offers at this moment. A decision made yesterday can protect you today, while restraint today can protect someone tomorrow. Food becomes a link between different moments and different people. But if you save food, who guards it? If you brought it back, does it belong to you, your family, or the group? Delayed consumption requires memory and trust. Together with preservation and storage, cooking transformed a meal from something in the present into protection for a future not yet arrived. The hearth directed attention toward food changing now and people who might need it later. Humans could act for a tomorrow they imagined but could not guarantee. Step back, and cooking reveals a broader human difference. Most species adapt through bodies and behavior to inherited environments. But look again at your own body. Humans evolved biologically too, while increasingly solving problems outside the body instead of waiting for anatomy alone. Before a modern meal enters your body, stone, and later the knife, divides food into smaller pieces. Fire alters its physical and chemical structure. Containers hold it. Social rules distribute it. Memory preserves the procedure. Researchers call this feedback niche construction. Organisms modify surroundings that then create new pressures. Once generations grew up eating processed food and guarding hearths, culture began shaping the conditions under which biology operated. You can see the loop. Bodies make tools, tools transform food, transformed food supports bodies, and children inherit both anatomy and technique. No single element acts alone. Human evolution increasingly unfolds through a system in which biology and culture repeatedly alter one another. This was not victory over evolution. Dependence brings vulnerability. Fire needs fuel, and processed food needs tools and support. Technology changes our relationship with nature. It does not remove us from it. Small teeth and expensive brains are a trade-off. Survival became distributed across anatomy, tools, knowledge, cooperation, and modified landscapes. So where does your body truly end? At your skin, or does it extend into the knife, the pot, and the flame? A hearth is a biological function performed outside biological tissue. It does work that teeth and intestines would otherwise do, but operates only because people gather fuel, control heat, remember timing, and share knowledge. The deepest change was not that humans escaped dependence. It was that we became dependent on one another and on environments we learned to build. Now return to an ordinary modern kitchen. The ancient flame may hide beneath glass or be replaced by induction. You need not gather wood, preserve embers, or fear predators. One of humanity's oldest technologies has become almost invisible. We may never identify a first cook. Perhaps someone recovered food from a natural fire. Perhaps many groups discovered the effect independently. The decisive event was probably not one brilliant moment. It was a chain of smaller ones. Someone tasted a change, remembered it, and tried again. Eventually, someone younger reproduced the method after the discoverer was gone. Heat made food easier to chew, increased obtainable energy, reduced biological risks, expanded resources, created gathering places, and turned discovery into shared knowledge. But the earliest motive may have been much simpler. A food changed by heat was worth approaching again. No first cook could foresee the consequences. Processing supported costly brains. Waiting encouraged coordination. Hearths reorganized space. And preserved food carried energy toward an uncertain future. What began as a response to hunger became a daily environment in which food was cut, softened, heated, shared, and remembered. So the next time you stand before a cooked meal, look at it a little longer. Before food reaches your stomach, tools have divided it, heat has changed it, and inherited knowledge has directed the process. Digestion does not begin in the mouth. It begins in a cultural system outside the body. Our ancestors needed no knowledge of starch, microbes, or calories, only observation, memory, and the willingness to repeat a useful result. Humans learned to place part of the work of survival into stone, flame, practice, and one another. From those hearths came more than dinner. Time saved from chewing, food reserved for tomorrow, knowledge that outlived its discoverer, and a species able to reshape nature before nature reshaped the body. Cooking did not happen after the human story was complete. It became one of the processes through which that story was written. And the next time you turn on a stove, you might ask yourself, are you merely preparing a meal or repeating an ancient act that helped shape the human body and the life you live today?